here we go. Please label your notes as simplest radical form. Simplest radical form. Now, a couple days ago, we worked on finding prime factors, and the reason we did that was a skill that you had to have in order to be able to put things in what we call simplest radical form. So let's start by saying, what is the square root of 100? It's 10, correct. What about the square root of, say, 36? What is that?
Positive and negative.
Yeah, and technically you're right. Positive and negative 10, positive and negative 6. But for the sake of this conversation, we're just going to concentrate on just saying 6 and 10 and so on. But when we start applying it, then we'll work on the positives and the negatives. But what if I give you a problem like this? Say, for example, the square root of, let's do the square root of 28. What is the square root of 28? Yeah.
Get the prime numbers.
Well, it gives us a decimal, right? So what we need to do is, in order to put this in what we call simplest radical form, we have to see if there are any perfect squares that are hidden inside of 10. And we're going to do that, yes, by listing all the prime factors of 28. So 100 is a perfect square. So the hidden perfect square inside this number is 10. 36, the square root of 36 is 6. So its hidden perfect square is 6. But 28 has a hidden perfect square, but we don't know what it is until we make our factor tree. So what you need to do is the same thing we did the other day. Do your tree for 28. 28 is even. So you know you can divide 28 by 2. 2 and 14. All right? So I'm going to circle the 2 because I know 2 is prime. And then 14, I can break that down to 2 and 7. 2 is prime. Is 7 prime?
Yes.
Yes. The only things that will multiply to give you 7 are 1 and 7. So 7 is prime. So, because 2 shows up twice, what is 2 times 2?
4.
2 times 2 is 2 squared, which is 4. So, what is the square root of 4? It is 2. So that means that the square root that is hidden inside of 28 is 4. So what do you need to write outside of here? Well, this is equal to, we have a pair of 2's. So since it is a pair of 2's, means 2 times 2 is 4, the square root of 4 is 2, that means I'm going to write it down one time. So every time you see a pair of numbers, you write that pair down one time. A pair makes one number. Are you okay with that? Because just like the square root of 100, that means 10, a square root of 10 times 10. 10 comes in a pair. 2 10s make 100. The square root of 100 is 10. All right, 7 is a leftover. It's lonely. It doesn't have a date to homecoming this weekend. Since it does not have a date, we are going to leave it at home underneath the radical sign. Aw, poor 7. So 28, the square root of 28, written in simplest radical form, is 2 square roots of 7. Let's try another one. Let's do the square root of, let's do 200. Some of you may look at that number and know exactly what perfect square is hidden inside of that number. But let's do the math anyway. What can I break 200 down into? 2 and 100. So do a tree. 2 and 100. 2 is prime, so we circle it. 100. What multiplies to give you 100? I can do 2 and 50. 2 times 50. 2 is prime, so I circle it. What about 50? Does anything multiply to give you 50?
25 and 2.
Can we do 5? Can we do 5 and 10? Just we're not doing 2 again. You could do 2 and it would work. Let's try something different. Let's here in the first example. You need to look for pairs of numbers. If there's a pair of numbers, you write it down one time. If there's leftovers, you leave them underneath the radical sign. So, okay, we'll get there, okay? We have a pair of 2's right here, so I write it down. That's 2. One pair makes one number. 2 5's. Would you agree? A pair of 5's. So I multiply that by 5. I write it down one time. One pair makes one number, but I need to multiply them up here. There's one left over, doesn't have a date to homecoming, it has to stay home underneath the radical sign. Oh. What is 2 times 5? 10. 10 radical 2. That is 200 written in simplest radical form. Let's try another one. Let's do the square root of, actually, you know what I think I'm going to do is grab myself a new page here. Okay. Let's do the square root of 78. Square root of 78. What multiplies to give you 78? Divided by 2. Start with 2.
Oh, I divided by 3.
Oh, I think 3 would work too.
It
Yeah,
does.
6 and 13.
6 and 13. Alright, you guys, now I gotta use my eraser. Okay, no, we're gonna do 2. 2 and I think it's 39. Okay? 39. 39, now do 3. 13. That gets you 3 and 13. 3 is prime, 2 is prime. What about 13? Is 13 prime?
Yes.
Yeah. Do we have any pairs?
No.
We have no pairs. Since there are no pairs, that means each one of these 3 numbers are going to stay home, all underneath the radical. So I draw my radical sign, and I have a 2, a 3, and a 13, all leftovers. 2 times 3 times 13. So we multiply them all. 2 times 3 times 13 is
78.
Oh, isn't that what we started with? Okay, so the reason I did this with you is because sometimes you have a number that is already in simplest radical form. And you might not know it's in simplest radical form, but if this happens, if you end up with no pairs of numbers, that means it's already in simplest radical form. Okay? Alright, something else I want to mention is this. What if you get a situation like this? Let's do the square root of 625. And you think, okay, let's do my tree. And you could do a tree and it would all work out and everything else. But I want you to check before you do your trees for every one of these problems. I want you to check if this is a perfect square to begin with. Check. Is the square root of 625 a non-decimal number?
Yes.
What is it?
25.
25. So there's no, you don't need to do a tree. The square root of 625 is 25. If you did the tree, you would end up with no leftovers, and the numbers that you would put up here would all multiply to 25 anyway. Should we do the tree anyway, just for fun? Yeah, we should. You're right. Okay. 625. 25 and, help me out here, 625 divided by 25 is what?
25.
Why did I just say that? Let's pretend that I never said that, okay? 25 and 25. Yes, oh my gosh. 25. What multiplies to give you 25? 5 and 5. Both prime, so I circle them. What about this 25?
They're both 5.
5 and 5. I circle them. Alright, and every time you have a pair, every time you have a pair, you need to write it down once. So these two are a pair. So we write it down. These two are a pair. So we write it down. So we have 5 times 5 is equal to 25. There's no leftovers. So you will have nothing. Nobody's going to stay home. You're right in people's way. No one's going to stay home. Everyone has a date to homecoming. There's no leftovers. So we have nothing left underneath the radical sign.